Now I'm going to show you how to plot phase ABC. Recall last time we mentioned that when we want to plot a sine wave, we can define the frequency equals to 60, and then we can define the magnitude. Remember that magnitude is actually RMS value times square root of QRT of 2. So if you want the RMS value to be 120 volt, then the magnitude of voltage need to be 120 times square root of 2. And then omega actually need to times the frequency. Last time I just put 2 pi there. That means the frequency is 1. But in our AC current, the frequency is actually 60. So we times the frequency right here. And then angle 0, that's basically the initial angle that you have. That's the phase shift. Suppose we have the initial angle that is 0 degree. We usually mention degree in our like. So if we want to change them to radius, we need to divide them by 360, which is 2 pi times 2 pi. That it would just convert the degree into radian. So convert the degree into radian. And then we need to define the time. In MATLAB, everything is working in the format of a matrix. So we have time from 0 with a step change of 0.001, that's 1 millisecond. And then I want it to be 3 cycles, because 1 cycle will be basically 1 over frequency. You can see that if I do that, when you plot it out, it's 1 cycle. But if I want to be 2, then I want the end time to be 2 divided by the frequency. So that's basically 2 cycles. Let's take a look. So 1 cycle and 2 cycle, 2 cycles. So here I want to be 3 cycles, so I put 3 here. And then I can just use voltage equals the magnitude times sine omega times the time, and then plus the initial angle. Recall that usually we would do cosine instead of sine, so we put cosine here, and then that equally well. But when you plot it out, you can find that it starts from when the phase is 0, it starts from the peak value here. So this is how you plot out a single phase voltage waveform. Suppose you want to plot 3-phase voltage waveform, what should you do? Then what you would do is basically just plot them out 3 times with different initial phase angles. When you do plot, MATLAB use plot. This is the command. Usually you can name the figures. You can say figure 1 or figure 10. So the difference here is you just have a different figure open. But this figure 10 is not the title. You can actually put a title here. Say, let me just give a title, P-I-D-L-E, title, single phase voltage. And then that's the title. And then you can give a label. The label of x-axis is time, and then y-axis is voltage. And then again, this is the color. Basically, you can have a number of colors. You can have red, you can have green, you can have black, you can have yellow, you can have magenta, you can have blue. And then you have a canyon. So that's the one that I can remember. You can try them all. And then you can just say, hold on. That means that when you plot another waveform, it would just plot on the same figure without overriding this one. For example, if we do another one, just say, hey, let's put this initial angle to a different value here. Say minus 120 degree, and then let's calculate the voltage again right here, and then let's plot this out. Control C. So this basically I'll say another one. Say this is red. This is green. That's my phase B. And then you will find out if I plot them out. See, the green one will not, when you plot the green one, the red one will not disappear. So basically, you can plot your phase A and phase B. Similarly, you can plot out your phase C here too. Then I'm just going to say plus. Remember the phase shift of different figures. Let's say yellow. And then what you have is you have phase A, B, and C. But it's unclear that which one is which. So usually what we would do is that we do one, let's hope it's right, A, and C. See what it will do. You basically just can click this and then press F9. Oops, maybe I'll just do it all over again. Okay. Say here A, that's the red, and B is green, and then C is yellow. So by this way, you can just plot out different type of waveforms. Just try to see if you have three phase, and then you add them up, whether or not they're zero, that kind of thing. So suppose we change the magnitude here a little bit. Say we change this to 240. What will happen? Oh, this is bigger, right? So by doing that, you can just basically play with different combinations. And then here I actually put them in one figure. You can see that you just basically plotted them out. I'll put that in the Moodle site so you can download and play with it.